Hello everyone, and welcome to this webinar, Building an Integral Urban Model in 15 minutes. The contents of the webinar is as follows. First of all, I'm going to give you a really short introduction of 3DI and new developments, and then Leendert will give a demo with building an integral urban model, and then if all is well, we have some time left for some Q&A. So if you have any questions during this webinar, in the panel you have a questions panel. Feel free to ask any question that you have, and we'll come back to that at the end of the webinar. So first of all, let's shortly introduce ourselves. Leendert?
Yes, hi, good morning. My name is Leendert van Wolfswinkel. I'm a 3DI product owner, which means that I'm responsible for the product development of 3DI.
Thank you. My name is Jonas van Schoenstein Landman, and I'm the product manager of Nederlands Schuurmans Technology. And I will give you a short introduction of 3DI. The reason we do that is that we see that quite some part of the audience that we have in this webinar is probably not familiar with 3DI in general. So I give a short, brief introduction. If you'd like to know more about 3DI, feel free to also visit our website, 3diwatermanagement.com, or reach out for a product demonstration. 3DI is hydrodynamic modeling software in the cloud, is being developed by Nederlands Schuurmans Technology. With 3DI, we aim to follow every drop of water. And there are quite some unique, distinct features of 3DI that I will briefly address. But also in this webinar, we will introduce our other technology, which is called Lizard, which is a data warehouse and analytics platform, which you can use to build and manage your water information systems. And of course, we have also capacity building and support to help you assist in building your hydrodynamic simulation models. We are not only building the software, we're also using it ourselves. So we love to get your feedback, but due to our knowledge of the domain, helps us create better software for you. So what is 3DI? 3DI is basically hydrodynamic simulations, interactive and online. And if you go to our website, you can see that you can also get a free trial or book a product demonstration if you need to. So if you, after this webinar, would like to test it out yourself, just hit the get a free trial button and we'll set it up for you. So regarding 3DI, we started the development back in 2010 together with Stelling Hydraulics, Deltares, TU Delft, and Nele and Schuurmans. It is currently being distributed and developed by Nederlands Schuurmans. And as we said, what we do is software development built with expertise in the water domain. So the characteristics are basically as follows. What we always have to say, we solve the full Saint-Venant equations. Thanks to Subgrid, we can compute large areas on a high resolution. So basically, we compute on a different resolution than the digital elevation model, while still taking the high resolution into account. We aim to follow every drop of water above and underground. So we have overland flow, sewerage flow, groundwater flow, and everything combined. The 3DI model building is fully GIS based. What we notice is that if you build a schematization, then a lot of this work is basically GIS. So what we have done is we have integrated the model building fully into a GIS environment. Also, as I mentioned, it's cloud-based hydrodynamic modeling software, and you can also interact with your 3DI simulation in the browser, which you can do using 3DI Live. If we have time, we might show you at the end of the webinar. Otherwise, I would be happy to refer you to our website or our YouTube channel where you can find demos for the 3DI Live. And of course, it's not only that you can interact in the browser, but since 3DI is built API first, you can also fully control and interact with your 3DI simulation using the Open API, which also means that you can automate every step in the modeling process. You don't have to. I mean, it's nice for those of you that are tech savvy and like to automate everything. We have also built user interfaces that help you assist in building your schematization. And that is, of course, part of this webinar where Leendert will show you with the modeler interface how he is going to build a 3DI schematization for an urban area. I'm not going to explain now what is SubGrid and how it works, but I'm just going to show you the benefits. Here, what we see is a flood simulation. On the left-hand side, we see it with SubGrid. On the right-hand side, we see it without SubGrid. And the computational cells, the number of computational cells and the size of the computational cells, everything is the same. So, and the computational speed is the same. But on the left-hand side, we take the high resolution into account. On the right-hand side, we say, okay, let's do a, for example, depth average per cell. There are several ways of coping, of course, with a elevation in a computational cell. The depth average is quite common. And what we see is that, yeah, everything is the same, except that the result is completely different. And this is for a relatively small area, but you can imagine if you use SubGrid that it also means that you are able to compute for larger areas than you can do without SubGrid technology. The result is different. So yeah, let's go to the topic of the webinar today. We are going to build an integral model, a model which includes flow above and under the surface. It's always good to just introduce what are we going to, what do we mean, what is an integral model? Well, in today's example, we are going to include rain on grid and buildings. So the rain will fall on the digital elevation model and on the buildings, and it will have overland flow, so the water will flow on the surface and also flow into the sewer system. Of course, the inflow in the sewer system is both via the buildings and via the surface. And of course, then we also include sewer system flow. Of course, this is what we picked for today's example. If you want to make like include different things, enhance it, use control structures, etc., everything in that is of course also possible. But yeah, we thought it is fun to try and see if we can build an integral model in 15 minutes, and then of course we have to make a selection of what we are going to show.
Next webinar we'll raise the stakes.
Yeah, next webinar we might raise the stakes. I think for 50 minutes it's already quite a challenge. Yeah, let's we'll see whether we can whether Leendert manages in 50 minutes. So what are we going to show in this webinar on the new tooling? Well, of course, the people that work with 3DI already know that that you can also use a lizard in your workflow. So how does that work? On the left-hand side, we have 3DI hydrodynamic modeling software. On the right-hand side, we have the lizard, the data warehouse and analytics platform. And you can, for example, extract data for model building from lizard. For example, the rasters or the time series or rainfall radar, because that is stored in this data warehouse and analytics platform, and then use that as input for your schematization. And of course, after you have done a simulation on the servers, yeah, you might want to store it for a long-term storage. You want to maybe use it 1 year from now. You don't want to download everything. So then you can store it in the Lizard platform. And of course, you can also do some automated post-processing. For example, arrival times, which is not part of the default output of a hydrodynamic modeling software, at least not with 3DI, but with automated post-processing, you can easily achieve that. And part of this webinar is that we are going to show the plugin that we built that is, I think it's part of the model interface right now. Yeah. So if you have installed the model interface, then it is automatically included in your installation, and you can use it to download rasters if you, of course, have also the access to the Lizard data warehouse. Another thing that we have introduced recently is the vector data importer, which helps you import data in batch. So in this screenshot, in this example, we see you select a source pipe layer, for example, shapefile. I mean, it's like 20, 30 years old data set, but we still see that people use it. You can select it as a source pipe layer, and you can then select the source attributes. Okay, for example, I have a shapefile with sewage pipes. I have invert level start, invert level end, but these names might be a little bit different, of course, in your source. So then you combine, you select which is which, and then you import it into your 3DI schematization. In the Netherlands, we also have something which is called GWSW Helix, and that is a standardized way of importing, of exchanging, I should say, sewage data, and that you can use also, of course. And if there is, if you are from a different country and there is like a certain standard that is used for exchange, then feel free to ask if we can support that. Of course, after you import the data and you build your schematization, there are, I counted them yesterday, I think there were 1,200 checks at the moment. And these help you in building your schematization. And of course, it's important to know that an error means that it is not possible to build a model from your schematization, for example, because you're missing a profile. Or a cross section or a diameter for your pipe. I mean, then the computational software doesn't know what to do. And the other thing that we are going to show is a few new processing algorithms. I think for those of you that don't know, there are some processing algorithms available in the model interface, and we have enhanced them with two new algorithms, or at least these two we are going to show in this webinar, which is called manhole bottom level from pipes, which basically means that you take the bottom level from the invert levels of the pipes that are connected to the manhole. I'm looking at Lena to check if I'm saying this right. And the reason that you might need this is because manhole bottom levels are not always part of the management software that is used within, for example, municipalities or governmental agencies that have these data, and then you need to have like an easy assumption of how what the bottom level is. And the other one is, of course, to map surfaces to connection nodes. And this can be surfaces or impervious surfaces. So, for example, you have a data set of buildings and you want to connect them to your sewage system and compute the inflow into this sewage system. Then this algorithm helps you to automatically map them. And of course, you can manually adjust this mapping afterwards. That's not part of this webinar, but that is also good to know that that is possible. I think that is part of my introduction. I think, Lane, that I'm going to make you a presenter.
Yes, thank you very much. Yeah, before I start the clock, I think it's nice to know what city I am taking as an example. The city is called Regina. That's the capital of Saskatchewan, if I pronounce it correctly, province of Canada. It looks like this. It has it's a city of about 250,000 population, and they have a very good open data platform, which allows you to download, well, in this case, for example, sewerage data. They also have open data for their digital elevation model with 1 meter resolution. So this is a very nice example, and also shows the power of making your data open. Let's Yeah, shall I start the clock, Jonas?
Yeah, maybe it's good to know what we are going to try here. Is Leendert is going to build a model in 15 minutes. It's basically a challenge that we have set. See if we can make that. And I will, in the meantime, just briefly introduce what he is doing, so he can focus on his work. And not have to think about what he is going to talk about at the meantime. So this is a new format. Let's see how it goes. And well, if you're ready, Leendert, then feel free to start the clock. Yeah. Let's start.
Let's go.
Okay. First of all, we're going to zoom into the model extent of the area that we are interested in. We are going to connect to Lizard using the Lizard plugin and download the digital elevation model. Oh, sorry, we are adding the digital elevation model as a WMS into the Lizard. Into the model interface. So what you see here is basically the digital terrain model of Regina. And we have first added it as a WMS, and now we are going to download the data also from the Lizard platform. We have selected a location on the computer where we are going to store it. We are going to give it a nice name so we can find it back. And then the raster dataset is being downloaded. So while that is being downloaded, Leendert is going to start up the Models and Simulations plugin, and he's going to create a new schematization. So he uses an empty spatial light dataset for it. We use a projection for the area, which is basically UTM zone 13N. We are going to enter some default values for friction, some default simulation time steps, and we are going to create a schematization. So after this is done, we can see that the schematization is created successfully, and Leendert is going to load this schematization into the model interface, and if all is well, we see almost, basically only the empty layers, because this is a new model. So what we see is that it contains no data at the moment. So what we first are doing is add some default settings. As you see, sometimes the view of the settings is in table view, and on the right bottom corner you can set it to the form view. Leendert is going to refer to the DEM file on his laptop, which is downloading, I think, at the moment. And the initial water level, I think he has looked it up on beforehand, is 568 meters mean sea level. In the meantime, the raster dataset from Lizard has been downloaded, and also we see it now in our screen. In the meantime, Leendert is going to import the manholes from Regina, which is a, I think, a JSON file. So apparently these datasets we have as a JSON file available. JSON is also a GeoJSON. Is the GeoJSON?
No, the JSON is the configuration for the import.
Oh, sorry. The JSON is the configuration for the import, and then first we start with the culverts that are available in this area, and we are going to load this as well. So features are successfully imported. So with this configuration is basically a predefined set for these data sets that are available, and then of course we need to have the DEM below the data set. I was also wondering, where is the data now? It is below the digital elevation model. And what we see here is the imported manholes, I think. And now we are also going to import the pipes, and we're going to run the importer. And now basically what we have is a sewerage network, a digital elevation model, and manholes. Of course, we want to have bottom levels. These are not available in the dataset itself, so we are now running the processing algorithm, which gets the manhole bottom level from the pipes. So that data is now also accounted for. We save what we have edited, and
okay, I'm just setting the calculation types outside of the 2D extent correctly.
Okay, we have of course different computational settings for if manholes are within or without the extent that we are that we want to compute. And basically opening the table, selecting a subset, and then setting a value, and then only update the selected is a nice way of doing a batch update for only the selection of the data set that you have. A different way would be to use SQL language, which is for the more tech-savvy users. I think this way of updating the tables is a nice way for people that don't want to go into SQL language. So let me check where we are in the script.
I'm going too fast, huh?
Yep, no, you're going nicely, I think. So what we are now going to add is some surface parameters. So you are going to add some default surfaces. With some default, well, outflow delay, I guess. And then, yeah, I was looking for that one. The building footprints also downloaded from the open data set. They're available as a well, geodata. I'm not sure what is the file format, but of course, then it is not already in the data of the 3DI schematization.
Okay, so I selected the buildings that I need. I copy them to the schematization.
So copying them is basically you make the layer editable. You select them from the source layer that you take them from, and you basically do well the well-known control copy, control V, and then we have the data imported in the 3DI schematization. I think there's currently a small bug that the last one doesn't have an ID, so Leonard is fixing that. That bug will also be solved fairly quickly. Good to know. And
surface parameters ID.
Oh yeah, we have to set the surface parameters ID. First we did the settings in the surface parameters table, and basically we say they're all the same. So we are going to treat all the buildings in exactly the same way. And now we are waiting for this update to happen. In the bottom of the table, you can see the filters going up. It's at 23,000 now out of 27. 1,982 buildings. So almost finished. And there we go.
Okay.
Cool. So now we're going to map these buildings to the sewer system. So we're going to select the impervious surface layer, which is called surface in this case. We're going to connect this to the connection node layer. We had at a search distance of 100 meters because the buildings are in some cases 100 meters away from a connection node, I guess. And what the algorithm does is it simply is a nearest neighbor algorithm, something like that. It looks for the nearest connection node for every building. Now we have downloaded this data set, but what we see is that it also works on WFS data sets. So for example, in Denmark or the Netherlands, you have buildings also served as a WFS layer, and then you just can directly also copy paste them from this WFS layer. So there are multiple ways of approaching this, and connecting the buildings to the and putting them in the schematization. So if there's time, we also you're going to rasterize something, which
yeah, I'm gonna.
Oh wait, you're going to take them out of the raster data set as well. That's nice. So the rain is on the buildings, and if you also have them in the raster data set as well, then the rain will both fall on the raster data set where the building is located as on the building. That will give you a bit of a double rain actually on the locations where the buildings are. So what Leonard did is he extracted that from the data set. So now he's ready for upload, and I think you gave your DEM file a slightly different name than you did in the settings. Then you need to press save to this. Oh wait, the save to spatial light option. Okay. So now we're ready for upload, and I'm curious because, okay, we are well within time. I know. What we see here is that there are some errors in the bottom levels. So the manhole bottom levels from the pipes somehow the manholes that are connected to the culverts also needed to be updated. That was a missing step in the script, I guess.
No, I just forgot it.
Yeah, that's actually what I meant. But so I'm curious. This is basically saving it, and what you also see. So a nice example: if you are trying to upload and you made some mistake, you get errors and warnings, and it helps you understand. Okay, something went wrong somewhere in the process. What do I need to do to fix it? So here we go to the top. We see that there are warnings. In a normal situation where we have more time, we would fix those warnings as well. But I guess for the 15 minutes challenge, we are accepting the fact that this is not going to be fixed for now. In a normal, if you are modeling yourself, I would always advise you to look at the warnings, and only if you fully understand them and decide that you don't want to fix them, then that's fine. But if you don't understand the warning, then also feel free to ask our service desk for what does it mean, and do I need to fix it? In most cases, the answer is yes, because with a warning, you can do a calculation, but it might affect your results. So what we have done now is we have started an upload. The spatial light has been uploaded. Because it's a new model, you also need to upload to them. We can argue whether this is part of the 15 minutes, because now you're basically waiting for the raster to be uploaded and the model to be generated as well. So there were no errors anymore, and the raster data set, how large is it?
It's not, yeah, I don't know. It's 100 megabytes. I think the upload speed is very slow because we are hosting the webinar.
It might affect you. Yeah, I think you can stop the timer while it stopped itself, but you could have stopped it earlier, actually. I mean, yeah, we have not defined the exact start and end for this, but to me, the moment you have added everything and there are no errors anymore, I'd say we have now a schematization. We're going to upload it and we're going to convert it to process it to a 3DI model, and we'll be able to show how it simulates. So if you have questions at this point, feel free to ask them in the question
chat
panel. Since you are presenter, I don't see them anymore for some reason. So no, there are questions in the question panel. All right. So it is uploaded. There was already one question from Denmark. Thank you. The question was, does 3DI support the Dundas format from Denmark? And the answer is that at the moment we do not support it, but I think if we have a look at it and see how we can, perhaps we can connect to it using the vector data importer. That would be relatively easy, I guess, to do so. But we also might need some guidance, because if I recall correctly, the Dundas format is described completely in Danish, which is fine, but a bit difficult sometimes to understand, even with Google Translate.
Yeah, maybe it's also good to emphasize that the vector data importers are they are generic for all types of GIS data. So all types of data that are supported by QGIS are also supported by this this importer.
Mm-hmm.
And that is actually, I think, almost any vector data format can be opened in QGIS. So that makes it a very versatile tool.
Okay. So
maybe I can stop sharing my screen.
No, I have found the panel. There's a question about the goal of the model. How do you say that? What are we trying to model here?
Yeah, so this is a very good question. I did not have a lot of time to go through all these important modeling questions in 15 minutes. But yeah, as you can see here, if I zoom out a little bit, this is the full data set of Regina the sewerage system. And as you can see, the model that I made is the northwestern part of Regina. Well, the objective that I had in mind for this model is to assess the effects of intense rainfall events on this part of the city. So I included the river that is eventually this whole part of the city drains to this river. In the end, there should also be a boundary condition here so the water can actually leave the area. But the sewer system is important because, of course, in a densely populated area, the drainage of excess rainwater, stormwater, is for a large part is done via the sewer system.
Yeah.
Okay.
Let's. There are quite some questions. Sorry. I think in the meantime you can also show it maybe on the live side, or shall we maybe first answer the questions first? That's maybe better.
Yeah.
There's a question about importing vector data with import schematization objects. Why can't multi-line string geometry be imported, and is it only permitted to import single line or curve types? That's a very technical question from obviously someone that already tried it.
Yeah.
So that's obviously for you.
Yeah. Wait. In the meantime, I will reload the schematization so it looks a bit better. Yeah, this is a very good question. As if you noticed during my workflow, the layers that I selected for import, they were called manholes ready for import and pipes and culverts ready for import. So I, in a real situation, you usually need a little bit more than 15 minutes, and most of that time is spent on what some people call data wrangling, getting the data that is supplied by the client or from an open data source, to check it to see if there are any errors, and there is no such thing as perfect data, so you always need to go through checking if some values are missing, deciding what you are supposed to do with those, and one step is also going from multi-part to single-part geometries, from curved geometries to simple geometries. And the way I did it is using the graphical modeler or the model designer in QGIS, so that I can also refer back to what I did, have a kind of a data trail. For example, for the manholes, I extract the manholes that have a certain type. I select the ones that are within my 1D extent. I extract the ones that are connected to pipes. And then here is the multi-part to single part algorithm, which QGIS automatically also converts curved geometries to normal geometries. And then I have this layer.
Yeah.
We have noticed that a lot of data that is available has either multi-parts or curved geometry. So this is very common, which is also a reason that we, in a later version, we will include it in the importer, so you can skip that step. But for the moment, you if you use this QGIS algorithm, then you're fine.
Yeah, this one that you're showing now, is that something you can we can share?
Definitely, yeah, sure.
Maybe we put it on the GitHub somewhere, on the GitHub repo of 3DI, or let's look at. Okay, we'll find a way of sharing it, and after the webinar, which is also being recorded, we will also share a location where you can find this, and you can also have a look at it yourself. Okay, let's go to the next question. Where did you got all the prepared JSON files, manholes, culvert, sewer system? Is it open data?
So the importer, it has two inputs. So one input is the source data. The other input is the configuration. The source data, well, that's what I showed at the start. I downloaded it from this open data portal, and then I use those graphical models to prepare them, to make them to select the right parts of the data set, and then I have these layers that are ready for import. And the other thing that the importer needs is a configuration file. And the way you make them is basically just filling in all these fields. So, for example, the code, I want to use an attribute from the source, and the attribute I want to use is the object ID. Mm-hmm. And I do this for all target fields. So for the calculation type, I just want to set them all to isolated. And then I go through all these. This takes a bit of time, but if you, for example, for Regina, if you need to build 5 models or 6 for the different parts of the city, you will have to repeat the same process, and you can, once you have filled in all these fields, you can save it as a template. So let's say which are the import configurations pipe import config. Okay, and that's a JSON file. And then if I do it again, do the pipes, and then I load that template, mm-hmm. Then you see that the code uses the object ID as a source. So that's what I did for all these fields, and also for the connection nodes that are created, the manuals that are created. I filled it all in, and then if it's
yeah. So there's a question about that. Do we have predefined configurations for InfoWorks shape files?
Not yet. No.
Okay, no. But if we have them, we'd be happy to share them. Where can I find the feature map in Purview services to connection nodes in the model interface? That's a good question. You were, of course, quite quick. It is being recorded, but Leonard will show you.
Yes, I think that this specific feature has not yet been released.
It's a beta.
So it's and it will be released this week. So you will need to have a little bit of patience and then update your schematization editor plugin, and then you can find it here in the inflow category of the 3D schematization editor processing algorithms, and that's where you can find it.
And now the question that I also would like to answer to. Please show some performance of the generated model.
Okay.
I'm very curious here.
I'm also curious. I did start a simulation, which is finished, so that's good news.
Can you show it on the live site, or is that not?
Yeah, I can download this, and also.
Am I asking?
Well, no, sure, that is no problem. Well, if performance-wise, I did a simulation with 2 hours of rain and 1 hour dry afterwards, so 3 hours in total, and it took 5 minutes and 15 seconds. And if
well, it's always nice to see it live, no? I prefer that. 5 minutes is not really long. But this is a raw model, as in has not been checked for performance or anything actually. So basically, this is just from scratch. If you can zoom in a little bit, maybe then we can see the pipes, the flow going through the pipes with the flows. These have been changed. If you know the old live sites, then you know these were dots, and we have changed that to flow in a different way, actually, the animation.
Yeah, another thing you notice here is that these flows are purple, which means the flow is faster than I think 2 meters per second.
Something you can set yourself?
So yeah, it's highlighted above 2 meters per second. If you want the threshold to be lower than like 1 meter per second, then it
yeah, so hydraulic problems where maybe pipes are too narrow might be found like this quite easily during the simulation. What you also notice is there's a little bit of flow on the surface, and that is the 2D runoff that is being shown right now. So I think that is an answer to that question. Let me go through the question panel. We are not finished yet. Okay. Okay, another question about the toolbox that has been answered. So it will be released later this week. So we're on Thursday. So I guess if you check it on Monday, you're good. Does the manhole level tool override all filled-in values, Leonard?
Yeah, that's optional. So you can check the box override existing bottom levels. By default, it's not checked, but and there's also an option to if you override it, sometimes you only want to lower existing values and not make them higher. So there's also an option for that.
Yeah, okay, because okay. Theoretically, it could also be that they're way too low, but you can use this tool, very versatile. I think this answers this question. The other question is, could we import 3DI and Lizard and QGIS as a plugin? Just shortly, what we have built here with the modeler interface is pre-installed plugins for 3DI and Lizard. So if you install the modeler interface, you have all the plugins, all the right versions, that's everything connected, working together. If you only want to use QGIS, you can also install the plugins separately. Keep in mind that when updating plugins, you need to update all of them. So the question is it being recorded? Yes, it is being recorded, and the recording will be sent to everyone that has registered to this webinar, whether they are attending live or not. It doesn't matter. And also, if you want to follow it later or send it to someone that you know, they can also find the recording later. Could we develop and see animations in QGIS 3DI? So maybe you can show a bit of the results analysis here. It's a good question.
Yeah, also this is interesting, an interesting feature of this Lizard plugin. So if so I also stored the simulation I just ran in Lizard, and I can add those as a WMS layer. And then I can show the water depth through time. And let's say I take
no, that's one, the water depth, but basically animation. So you can also use the results analysis tool, and you can show animations over the flow lines, either 1D, 2D. So I think actually for this question, we will include the results analysis webinar that we have given in the past, where we are showing you how that all works in QGIS or the modeler interface. I think that is a way better answer than we can give now. We have only 9 minutes left and some questions left, so I would like to do it like that. I need to write that down as well, otherwise I forget. If you can set up a model in 15 minutes, would you offer to set up a model at the cost of 1 day? That's of course the question that we could expect. That's a good question. I think it really depends on how well the data is. As Leendert says, the largest part of this is preparing the data set. So of course we have set up this model in 15 minutes. However, I think Leendert spent a bit more time perhaps preparing the data sets and putting them ready. So I think it really depends on what you want to achieve with this model. But I think with the tooling that we have, it will be a way for modelers to be able to more quickly set up models, and also perhaps avoid maybe mistakes that you would otherwise have made.
Yeah, and I think, of course, for this demo, I cut some corners in terms of the data that I encountered. So if there was pipes or other parts of the data that were not good, I basically threw them out and did not use them. If you want to build a real model, this would be feedback to the client that supplied the data, and you will have to have a conversation about how are we going to approach this. Yeah. Also, I would like to stress that if you are building a model in a real situation where there's no clock at the top of your screen, you should not do it in this way. You should really build a 2D model first, run some simulations, see how it behaves, then add perhaps the culverts, see how the model behaves when you add those. Yeah. Try to understand every step, every complexity that you add. Try to understand how it affects your model, and that's also what I did when I was preparing this. Yeah. And then, yeah.
But of course, we also already have some models for this client. But I think if you're interested, please contact me after the webinar. And if you have some data sets that you are thinking of that you want to have a model of, then feel free to send them. We can have a check and estimate how much time we think it would take to build a 1D, 2D model, as we have seen here in the simulation. I think we are going to the last question at the moment. How did you set the grid size of the 2D model using grid refinement? Can you explain how you did that?
Yes.
That's that went quite quick, yeah.
Yes. Okay. Let's just. So if you. Yeah, so if you look at the screen, you see all these green little lines. They are actually copies of the geometries of the culverts. So if there is a culvert here, there is also a grid refinement, and it has a refinement level of 1. Refinement level 1, and then if I look at the settings,
you basically copy pasted the data from the culvert.
Yeah, I just selected all the culverts, then copy them, make the grid refinement layer editable, paste them, and that's it. Then in the settings, I have a minimum cell size or grid space of 10 meters, and the number of grid levels, or the K max, is 3. So I have, if the refinement level is 1, there the cells are going to be 10 by 10, and then around it, it's going to be 20 by 20, and further it's going to be 40 by 40. That's
okay. I think let's wrap it up. If you have any other questions, then feel free to contact us. I will briefly share my screen with all the contact details and where you can get more information. So if all is well, I am now sharing my screen, and there is of course several ways of being in contact. You can either subscribe to release mails or newsletters. We have of course a LinkedIn page, a YouTube channel as well, and we are combining all the webinars also on our website. And if you want to read the science behind 3DI, then all the publications that are there we have summarized, and you can of course read the user documentation as well. I shared a slide earlier on 3diwatermanagement.com. You can also now, if you go to the homepage, get a free trial if you're interested, or book a product demonstration, and then one of us will help you show a bit more in depth the part of 3DI that you're interested in. And these are our contact details. Feel free to reach out if you have any questions unanswered after this webinar. We will either tomorrow or beginning next week share the presentation as well, and the recording, and feel free to share this also with anyone you think might be interested. So that's it. I would like to thank you all for your attention. Leendert, thank you for your nice demonstration. Easily within the 15 minutes, I'd say. So yeah, congratulations. Very nicely done. And well, that's it. And